Okay, so in this next video we have a couple more examples with converting from degrees to radians, radians to degrees. So if you notice here though, this one has this value. It says negative 3.91. So negative 3.91, but it says it's a radian angle. So even though there's no pi there, we can have it as a radian angle measurement. We're going to round it to the nearest tenth of a degree. So here's what I want you to think about. Pi is a radian measure, which is equal to 3.14. So we can express either one of these as the radian measure. Notice the one thing missing, there is no degree symbol. Okay, and that's how we know it's a radian measure. So that tells me that I need to do this conversion by multiplying by 180 over pi. Now this is definitely a calculator problem. You take out the calculator, you multiply across, so you take negative 3.91 times 180 divided by pi, and if we round, we're going to get a negative 224 degrees, 0.0. The degree measurement shouldn't be right there. It should be after the 0, so I apologize. Okay, so our next example, now this one is a little bit different. It says find the exact value of cosine of negative pi over 6. So what this is actually doing is it's saying, hey, find cosine of the angle. Well, but now instead of being in degrees, it's in radians. So right now the easiest way to do this is we have to convert to degrees, because that's going to make more sense to us right now. As you get more comfortable with this stuff, the pi over 6 is not going to cause any problems. So we take the pi over 6, multiply it by 180 over pi. The pi's cancel out, and this is a no calculator. How many times does 6 go into 18? 3 times. So that means that we have 30 degrees. So really this question, the same thing is, what's cosine of negative 30 degrees? Well, negative 30 degrees, I draw my triangle. I go backwards, right, because of the negative. It's a 30, 60, 90, so I label my 2, my 1, and my root 3, and I make sure that that 1 is negative, and now I just find cosine of that triangle, which is adjacent over hypotenuse, root 3 over 2. So the key is with this problem is it's same as what we've been doing before, but you take the radian value, convert it to degrees, and then it's just like what we've done in the previous chapters, previous sections.